Greetings and welcome to our presentation, where we'll be unraveling our amazing and dynamic Earth. I am Gogla, and I'm here today with my fellow groupmates, Ethan, Winston, Durga, and Chizao. We are very keen in presenting our consolidation that we've meticulously put together. In this presentation, we will be focusing on two segments, which are the internal structure of the Earth and the different types of plate movements taking place at plate boundaries.
The internal structure of the Earth essentially consists of three main layers of the Earth and are the core, mantle, and crust. However, these layers can be further broken down into the inner core, the outer core, the lower mantle, the upper mantle, the uppermost mantle, and the crust. Firstly, we will be tackling the core of the Earth. The core has the largest radius of 3,500 kilometers and is 2,900 kilometers below the surface of the Earth. That is actually approximately 70 times the length of Singapore, given that Singapore measures about 50 kilometers. The core also has an extreme temperature ranging from 3,000 to 500 degrees Celsius. The core mainly consists of iron and nickel. The core can also be divided into the inner core and the outer core. The inner core is about 1,400 kilometers thick and is solid due to extreme pressure exerted on it by the surrounding layers. The outer core is about 2,100 kilometers thick and is actually a liquid layer.
Next up is the mantle. The mantle lies above the core and occupies 80% of the Earth's volume. As for its thickness, the mantle is estimated to be 2,900 kilometers thick and is primarily made up of solid rock that flows under high temperatures and pressure. The temperature in the mantle roughly ranges from 800 to 3,000 degrees Celsius. The mantle can be split up into three layers as well, which are the lower mantle, upper mantle, and uppermost mantle. The most notable layers of the mantle are the upper mantle and the uppermost mantle. The upper mantle is where high temperatures, about 1000 degrees Celsius, and pressure brings rock close enough to their melting point for them to be easily deformed. The upper mantle is often referred to as the asthenosphere, which translates to the weak sphere. It is given this title mainly due to the fact that the upper mantle is actually in a ductile state. This means that it is not brittle and is able to be deformed without losing its toughness.
Unlike the upper mantle, the uppermost mantle is brittle and solid. Hence it shares the same characteristics as the crust, which is the Earth's outermost layer. This layer supports living things on the Earth and makes up less than 1% of the Earth's volume. As previously mentioned, the crust is similar to the uppermost mantle, as both of them are brittle and solid. The crust can be divided into the oceanic crust and the continental crust. The oceanic crust is the crust beneath the deep oceans, while the continental crust is the crust beneath the continents, or the shallow waters close to the continents. Oceanic crusts are thinner but denser, as they comprise of heavy and dense materials such as basalt. On the contrary, continental crusts are thicker but significantly lighter, as they are mostly made of granite. Oceanic crusts sink at subduction zones, as they are much denser than continental crusts. Consequently, they pull the rest of the plate behind it. This is also known as a slap pull force, and it, together with the convection currents within the mantle, is the reason why tectonic plates move. Subsequently, we will be explaining more about the different types of plate movements taking place at the plate boundaries.
Type of plate boundaries include the divergent plate boundaries, convergent plate boundaries, and transform plate boundaries. Divergent plate boundaries are areas where the tectonic plates move away from each other and are considered to be constructive as they extend land in the lithosphere. Convergent plate boundaries are areas where the tectonic plates move towards each other and at times subduct. They are considered to be destructive as they destroy the lithosphere. Lastly, the transform plate boundaries are areas where the tectonic plates slide past each other and are conservative, meaning they are neither constructive nor destructive.
Plate divergence involves tensional force due to the tectonic plates moving away from each other, causing fractures that allow magma to rise from the asthenosphere to fill the gap between the plates on the lithosphere. Resultant features formed by divergent plate movements include fractures or faults, earthquakes, and volcanic eruptions. These are two types of plate movements at divergent plate boundaries: oceanic-oceanic or OO, and continental-continental or CC plate divergence. OO plate divergence causes the emergence of new land in the form of mid-oceanic ridges, submarine volcanoes, and even volcanic islands above water level. This is due to faulting and seafloor spreading, which is a process that occurs when lava flows out onto the seafloor, cools and solidifies, creating a new seafloor. This eventually forms the mid-oceanic ridge. Magma also builds up above sea level at various points along the mid-oceanic ridge to form volcanoes, which are known as volcanic islands. An example of OO divergence resultant features caused by the North American plate and Eurasian plate moving away from each other, thus resulting in the formation of the Mid-Atlantic Ridge in the middle of the Atlantic Ocean and a chain of volcanic islands in the North Atlantic Ocean called the Azores. CC plate divergence formed rift valleys, rift lakes, rift volcanoes, and block mountains. A rift valley is a linear depression between two continental plates when they diverge, and block mountains or fault blocks are the blocks of land with steep slopes left standing higher than the surrounding land. Rift lakes and volcanoes are lakes and volcanoes that form around this rift valley system. These landforms are mainly caused by faulting of the two continental plates. An example that illustrates CC divergence is the East African Rift Valley system in Africa, which was caused by the Nubian boundary of the African plate moving away from the Somalian boundary of the African plate. This resulted in a number of rift valleys forming, ranging from 20 to 80 kilometers in length, active volcanoes, and accompanying block mountains. The formation of Erta El volcano in Ethiopia and Lake Victoria was also caused by this plate movement.
There are three types of plate movement: convergent plate boundaries, which are OO, CC, and OC plate convergence. OO convergence results in a number of landforms. As we previously brought up, oceanic crusts are denser and subduct under a continental crust, and in this case, a less dense oceanic crust. An older oceanic plate is denser than the younger one. Consequently, a deep oceanic trench is formed at the point of subduction, and the subducted oceanic plate causes mantle material above it to melt, forming magma, hence causing volcanoes to form on the less dense oceanic crust. Eventually, a chain of islands form due to magma rising through the crust to form volcanoes. This plate movement takes place at the subduction zone and involves processes of subduction and faulting. Additionally, it also involves compressional and slap-proof faults and causes earthquakes, fractures, faults, and volcanic eruptions. An example of OO convergence is the oceanic Pacific plate moving towards and subducting under the Philippine plate. Resultant features include the Mariana Trench found in the Pacific Ocean and the Mariana Islands.
Continental plates convergence result in fault mountains on both continental plates and plateau, which is a fairly level highland. When two continental plates converge and resist subduction, as both of them are too thick and buoyant, it causes the plate to break and slide along with the fractures in the crust. The collision of these plates gives rise to compressional force, creating a tremendous pressure and causes the layers of the rock on the upper part of the crust to compress together and fold upwards or sideways to form fault mountains. Fault mountains are often formed from sedimentary rocks because they are more flexible than igneous or metamorphic rocks. Besides folding, a reserve fault may occur when rocks are displaced due to compressional force and earthquakes. However, there is no volcanic activity found at this type of plate boundary. Therefore, this plate boundary takes place at the collision zone and involves the process of folding and faulting. As a result, earthquakes, faults, and fractures are caused. An example of continental convergence is the Indian plate and the Eurasian plate. that are continental plates of similar density converging, thus resulting in the formation of the Himalayan mountain range and the Tibetan plateau, which is formed on the Eurasian plate further due to the uplifting.
The OC convergence causes stratovolcanoes, volcanic arcs, fold mountains, and oceanic trench. When a thinner and a denser oceanic plate collides with a relatively thicker and less dense continental plate, the oceanic plate subducts under the continental plate. At the subduction zone, a long, narrow, deep oceanic trench is created along the plate boundary. The crust of the oceanic plate melts and forms magma. The magma rises through the mantle and the crust of the continental plate to emerge as stratovolcanoes on the less dense continental crust. Meanwhile, the edge of the thick continental plate buckles and folds to form fold mountains due to the immense pressure from the resultant compressional force when the plates collide. Fold mountains on the continental plate are caused due to folding and faulting. Earthquakes may also occur as there is friction between the oceanic and continental plate as they collide. Hence, the OC convergence occurs at the subduction zone and involves compressional force and the processes of subduction, folding, and faulting. Resultant features such as earthquakes, faults, volcanic eruptions, and fractures or faults are caused. An example of OC convergence is the Australian plate and the Eurasian plate converging, resulting in the formation of Barisan Mountains, Sondara Trench, and stratovolcanoes such as Mount Marapi and Mount Sinabang.
Transform plate movements result in no landforms. Transform plate boundaries are the areas where tectonic plates slide past each other, resulting in tremendous stress accumulating. This is eventually released in the form of violent earthquakes. This movement involves the process of faulting and shear force, causing earthquakes and fractures, or strike-slip faults. It is believed that this movement occurs due to the convergence and divergence of plates, pulling and pushing adjacent plates. There is no volcanic activity due to the lack of subduction. Neither is there disruption of the lithosphere. Thus, transform plate movements are considered to be conservative. An example of such movement is the San Andreas Fault between the Pacific Plate and the North American Plate. In 1906, an earthquake occurred in San Francisco, Southern California, the San Andreas Fault. As a result, several hundred kilometers of the North American Plate moved an average of 2.5 meters, and at one point almost 7 meters in less than 1 minute.